In this video, we'll be working some problems with angles given in radian measure. Our first problem is to evaluate 4 sine pi over 4 plus the sine of a negative pi over 3. Now what I would do is draw my reference triangles. Pi over 4 is in quadrant 1, and it's a 45-degree reference angle. And so we can put our values, 1, 1, root 2, in my reference triangle to use in just a minute. Now this one, a negative pi over 3, that one is in quadrant 4. Pi over 3 is the same as a 60-degree reference angle. And so I can put my 2 on the hypotenuse. And this angle is 30, so this side will be a 1, and then this side will be a root 3. Now we need a negative on this side that's below the x-axis. Okay, now let's put our ratios into the problem. I have 4 times, and then I need the sine of this angle. The sine is defined as opposite over hypotenuse. So the opposite side is 1, and the hypotenuse is the square root of 2. Plus, and then on this one, we just need the trig ratio. So sine is defined again, opposite over hypotenuse. So we have a negative square root of 3 over 2. If we multiply here, we'll get 4 over the square root of 2. And we need to rationalize this guy, so we'll multiply top and bottom by root 2. So I have 4 square root of 2 over 2. And then plus and minus is the same as minus. And then root 3 over 2. Now since these both have a common denominator of 2, I can put them together. And my final answer is 4 root 2 subtract root 3 divided by 2. Now notice we cannot combine the radical 2 and the radical 3, because even though they're both irrational, they need to be like terms in order to combine those. So this is our final answer. Let's do one more. We're asked to evaluate the sine of 13 pi over 4 plus 3 times the cosine of a negative 5 pi over 3. So let's look at 13 pi over 4. There's a number of ways to think about this. I personally think of 13 fourths as 3 1/4. So since I'm talking about that many pi, one semicircle is 1 pi. So from starting over here at the positive x-axis, I have 1 pi, and then 2 pi, and then 3 pi, and then 1/4 of a pi would put me in quadrant 3. Pi over 4 is a 45-degree reference angle, so we have a 1, 1, root 2, and this one is going left, so he needs a negative, and this one's down, so that needs a negative. So now I have my numbers ready to put into the problem. Let's draw our reference triangle for this one. 6 pi over 3 is 2 pi. So I know that this one is 1/3 short of a complete revolution, and it's a negative angle. So I'm going to start here and go around in the clockwise direction, and then stop at pi over 3, which is a 60-degree reference angle. If I put my numbers in, this will be 30, so we have 1, hypotenuse is 2, and a root 3. All of these sides are positive. So now we're ready to go. All I want is the sine of my reference angle here. Sine is opposite over hypotenuse. So that'll be a -1 over root 2 plus 3 times, and then I need the cosine of this reference angle. Cosine is adjacent over hypotenuse, so that's 1/2. Right? We need to rationalize our denominator, so we'll multiply top and bottom here by root 2. So this is -√2 over 2 plus, and then when we multiply here, we have 3 over 2. We have a common denominator, so we can put these into one fraction. Denominator is 2, and I have a -√2 plus 3 as my answer.